In this lesson, we're going to discuss some various encryption tools that are employed to protect our enterprise networks and systems. These encryption tools include things like the TPM, HSM, key management systems, and secure enclaves, and all of these play a crucial role in ensuring the data security and integrity that is occurring across all of our different platforms and environments. First, let's talk about TPM, or the Trusted Platform Module. At its core, the Trusted Platform Module, or TPM, is a dedicated microcontroller that's designed to secure hardware through integrated cryptographic keys. TPMs are going to offer hardware-level security that ensures that digital secrets remain confidential and unaltered. Think of it as a vault that ensures the information is remaining encrypted so that the system remains safeguarded from unauthorized access or potential tampering. One of the common uses of the Trusted Platform Module is with the BitLocker drive encryption feature found inside of your Windows operating system. By securing the cryptographic keys inside the isolated hardware, we add an additional layer of security against software-based attacks. Second, we have the HSM, also known as the Hardware Security Module. Now, if our TPM is like a personal vault, an HSM is like a high-security bank vault. It is a physical device that safeguards and manages digital keys and is primarily used for mission-critical situations like financial transactions. A hardware security module will perform encryption operations within a tamper-proof environment, and this makes it a reliable choice for sensitive operations. Not only does the hardware security module securely generate cryptographic keys, but it also can provide accelerated cryptographic operations, all within a tamper-resistant hardware device. Companies will often rely on hardware security modules to meet regulatory compliance standards, especially when they deal with highly sensitive data. For example, if an online retailer needed to make sure that each transaction is encrypted using keys generated and stored within their HSM, this could ensure that even if the retailer's system or databases were breached, the financial details about each transaction would remain safely encrypted due to the individual keys that are used by that hardware security module when encrypting that data that we're protecting using the system's encryption processes. Third, we have the key management system. Now, keys in the world of cryptography are really the lifeblood of the encryption process, and there are numerous keys that are going to be in play at any given time, and so it becomes imperative to have a system that manages, stores, distributes, and, when the time comes, retires or deletes these keys. This is where the key management system comes into play. A key management system, also known as a KMS, is an integrated approach for generating, distributing, and managing cryptographic keys for devices and applications. The key management system is a centralized mechanism that controls the entire lifecycle of these cryptographic keys from inception or creation to their eventual retirement and destruction. With the ever-growing cybersecurity challenges that are out there, having a robust key management system is really essential to preventing unauthorized access to your data. For example, if you're working for a digital media company with a requirement for a vast amount of cloud storage that needs to store all of your multimedia content, project files, contracts, and more, you want to ensure that each of those files is encrypted for security. Now, managing the unique encryption keys for each of these countless files manually would be a Herculean task. But with the key management system, you can ensure the system automatically manages those keys and refreshes them periodically to enhance security and to ensure that older keys are safely retired when new ones are being created and introduced into your system. Fourth and finally, we need to cover secure enclaves. Now, the secure enclave is a coprocessor that's integrated into the main processor of some devices and is designed with the sole purpose of ensuring data protection. Its architecture is such that it's isolated from the main processor and provides a shielded location for safe processing and storage of your sensitive data. I like to think about it like a fortress inside of your device, and it safeguards sensitive information like your fingerprints, facial recognition data, and Apple Pay info. By keeping this data separate from the main processor, even if the device gets compromised, the data within the secure enclave remains untouched. For example, most people are familiar with Apple's iPhone and its features like Face ID or, the older version, Touch ID. Behind the scenes of these two features, though, was the secure enclave in action. When the user sets up a facial ID scan, the facial recognition data is going to be stored inside the secure enclave and it will never leave the device. So even if somebody gains access to the phone, the data within the isolated environment will remain untouched. This guarantees that only after a successful biometric match within the secure enclave happens, that your device will be unlocked, and this makes it nearly impossible for unauthorized access to occur on those devices. So remember, understanding these encryption tools and how they work is pivotal in today's digital age. As cybersecurity threats evolve and grow in complexity, the importance of robust and efficient encryption mechanisms cannot be overstated. First, we have the Trusted Platform Module, which we commonly call the TPM, and this is a dedicated microcontroller designed to secure hardware through integrated cryptographic keys and offers hardware-level security to ensure the digital secrets remain confidential and unaltered. A hardware security module, or HSM, is a physical computing device that safeguards and manages digital keys for storing authentication that performs encryption operations within a tamper-proof environment. A key management system, or KMS, is an integrated and centralized approach to generating, distributing, and managing cryptographic keys for your devices and applications across the entire lifecycle of these cryptographic keys from creation to destruction. And the Secure Enclave is a coprocessor that's integrated into the main processor of some devices and is designed with the sole purpose of ensuring data protection that isolates the coprocessor from the main processor to provide a shielded location for the safe processing and storage of sensitive data. Also, as the technology continues to advance, it is really important that you keep yourself up to date on the latest tools and techniques to best protect your systems and networks.